Yes, uh, in previous class we have discussed about so many other concepts related to um, what was that? Related to flight maneuvers and some other topics. And stability and control part we have discussed in previous class, where we have seen different types of stabilities, whether it may be longitudinal stability or dynamic stability. And also in that we have seen subcategories: positive, negative and neutral, and statically stable and dynamically unstable, how the situation will be there. That also we have discussed. And now in today's class we will talk about aircraft performance. Aircraft performance. About this we will speak today. So when I say aircraft performance, it will include both the aspects. One is it's including engine-wise concept, that is propulsion related topic or performance, propulsion related performance. And next also it will include the concept of aerodynamic performance. Aerodynamic performance. So this propulsion performance and aerodynamic performance will be get affected by the increase in altitude. Increase in altitude. So as your aircraft climbs and reaches the higher altitude, okay, as increases its speed and climbing and reaching higher altitude, the performance related to propulsion and aerodynamic will get affected. So that topic also we will discuss today. So now when I say propulsion performance, it includes some concepts related to thrust available, thrust required, okay, power available, power required, minimum velocity, and maximum velocity. So all these concepts will come under propulsion related performance of the aircraft. So now aerodynamic performance will include drag curves, lift, etc. Okay, and now combining these we will study, and we will finally find out what is the performance of the aircraft based on different engines. So now we will see one by one. Before that, we will talk about effects of the effect of the altitude on aircraft engine performance. So first we'll go with that topic, then we'll come back to thrust available curves and drag curves. Effect of altitude on engine performance. on aircraft engine performance. And we know that, and in previous units we have studied that as you increase the altitude, or else if you just start climbing the altitude, what will happen to the air density? And we know that air density will start getting decreases or reduces as we climb to the higher altitude. So now, and also we know that the thrust generated by the engine, thrust generated by the engine is directly proportional to the what? The density of the airflow. So we can say that density of the airflow. Why? Because if we have the high amount of airflow, that means the mass flow rate of your air is more, which is going inside the engine. That means it will produce that much of combusted product or that much of hot gas, which in turn will go out through the nozzle and produces the thrust required for the aircraft. So that means if higher density, that means more density of the air, more thrust will be getting. This is one of the good performance. But what happens to the higher altitude? As you goes on increasing the altitude, the air will get less denser. The density of air will start getting reduced. So due to that, what will happen? We will not get sufficient amount of airflow or mass flow rate of air into the engine, where you cannot get the enough thrust to move. At that time, what we have to do? We have to consume more fuel. Yes or no? We have to consume more fuel, which will cause more money. That means the performance of your aircraft is getting reduced. So this is one aspect. And also the temperature increases. If you climb the altitude to the higher level, the temperature also starts getting increases, which in turn will create the randomness in the mass flow rate of the air, so that the air will get dispersed due to entropy, entropy concept. So because of this, you will not be having, first of all, the air density is less. In that also, due to the temperature, the air molecules will spread here and there, so that you will not get the enough amount of mass flow rate. So this is related to aircraft performance. So one thing is it will produce less thrust, and second thing is it will consume more fuel, and third thing is about aerodynamic part that we will see next later. So these two will come under propulsion performance, where it will not be your aircraft will not be that much efficient at higher altitude. That is the reason most of the aircraft will fly, basically for civilian aircraft will be in lower altitude, where huge amount of air is available. So what in case if your propeller aircraft engine moves? What in case your propeller engine moves in the higher altitude? Because most of the or 80% of thrust is produced due to the propeller of the aircraft, where at lower altitude the more air is there, so that it can take more air and send it back. Video ಮಾಡ್ತಿದ್ದೀರಾ? Okay. So it will take the air and send it back. In case in higher altitude there is no much air, so that it will also produce less amount of thrust, which is not helpful for the aircraft. So that is the reason many of the aircraft will fly in the lower altitude, where the more density of air is available. So this is in terms of propulsion related one. So what if you come to the point of aerodynamic point of view? So the lift generation, if there is good amount of air is there, then it will flow over the surface of the wing and it will produce good amount of lift. If there is no air, obviously lift will not be produced whatever we wanted to have. So that is the reason the density of the air will be the important parameter, or it will play a key role in order to keep your aircraft efficient one. Otherwise, it's not possible. So finally, the effect of altitude is what? It will reduce the performance of the aircraft in terms of thrust, in terms of fuel consumption, in terms of lift generation and everything. So this is about the effect of altitude on engine performance. So now we will study about some different performance curves. Okay. So first we'll start with the drag curves. Drag curve. Now we will discuss about drag curve. So what happens here? We will take the condition as per our syllabus, that steady state level condition. Okay, we will take the condition that is steady state level flight. Steady state level flight. So when I say steady state level flight, now we will consider one small picture of the aircraft. Now this is the aircraft which is in airborne condition and it is flying in the air. At this point, that is steady state level flight, at this condition what will happen? Here thrust is whatever it is producing T, and this side the drag will be produced, and in upper direction the lift will be produced, and in lower direction weight will be acting. So for steady state level flight condition, always it is like this. Whatever the thrust is produced, that is equal to the drag. Okay, and for whatever the lift is getting produces, that is equal to what? Sorry, that is equal to the weight of the aircraft. That means what? Your aircraft is like this, it is moving. Okay, when you have more thrust, it will get accelerated. Okay, that means what is overcoming from the drag. But if your whatever thrust is getting produced in this direction is equal to the drag, what will happen? It will not go, it will remain stand. Okay, so what if the lift is less and weight is more? It will come down. What if lift is more and weight is less? It will go up. But for steady state condition, what we want? We want both. That is, thrust produced equal to the drag and lift equals to the weight. That means it will stand still. Like this, we can move easily. Okay, without any disturbance. So for that purpose, this condition is there. Okay, so in this, thrust equal to drag and lift equal to weight. So now we are talking about drag curve. Basically, there are two different types of drags are there. One is called as induced drag. Induced drag, and another one is called as parasite drag. Okay. So now, what is induced drag? This drag, what is that, sir? Induced drag is what? The drag which is created or generated due to the lift. Okay. For example, your aircraft is climbing and it is increasing its climbing and it's increasing its angle of attack. Okay, what will happen? The lift will be acting perpendicular to the longitudinal axis. That we know that very well. Okay, so now the lift is generating this way and angle of attack is increasing. So what will happen? The air, whatever it is flowing, it will create the drag. It will try to, put your aircraft down. Okay, the aircraft is experiencing the drag. So that drag is called as induced drag. In simple words, we can say that induced drag is nothing but the drag is created due to the lift generation. That is one point. Second thing, parasite drag. What is parasite drag? Parasite drag is one kind of different drag, we can say, which is getting created due to the surfaces of the aircraft, because it may be due to the nose, due to the engine part, due to the tail plane, or due to the fuselage, whatever the body parts are there outward or in which are exposed to the atmosphere, it will create certain drag. How? By just going against the wind flow or air flow. It is like this. It is going like this. The wind is coming. It is applying on this or falling on this surface, and also it is creating certain drag. In similar manner, it's trying to push it in backward direction. So parasite drag means the drag which is created due to the aircraft components which are exposed to the atmospheric conditions or atmosphere, we can say. So now this induced drag and parasite drag both are related to, with respect to what, are related to the airspeed, we can say. So now I will draw one small curve for that, for a drag curve. We'll see how it looks. This side is airspeed. This is drag. So here stall speed is there. From here it will start. Why? Because in order to get your induced drag, basically you will get it when your aircraft is going to get stall more. That point. So now, as airspeed increases, your induced drag will reduces. Okay, induced drag reduces. So it will be more at the high angle of attack. Angle of attack. But as airspeed increases, you can bring back your nose of the airplane down. That means you can reduce the angle of attack and make it steady state level flight. So at that time, what will happen? The induced drag will start decreasing. Okay, it starts decreasing as your airspeed increases. Okay, it's like this. Aircraft is initially on ground, running, taking off, where your angle of attack is increases. Due to that, drag is created. Induced drag is created. So after a certain time, what will happen? It will become, it will reduce its nose down. That means it will reduce the angle of attack and it will become straight. Where lift generation is now here, it is little. That means the induced drag is getting decreased with respect to your airspeed. So now I will write this. This is induced drag or drag due to lift. So now one more is there, that is parasite drag. It will be initially less. When your aircraft is on ground, there is no parasite drag because it is not moving at all. That means there is no resistance, right? So once it starts moving, it will start experiencing the air at different parts which are exposed to the atmosphere. outside. Okay, so your parasite drag will be initially it will be less, then it starts increasing as your airspeed increases. So this is parasite drag. Okay, so that is parasite drag. So now this is why, because of the movement of the aircraft. Okay, so now let us say your nose is experiencing, or let us say I'm running, standing on ground. I can feel little amount of air which is falling on my face. But if I start running faster and faster, what will happen? I will experience the more air which is trying to pushing me back. That means I am experiencing more parasite drag. The same way for your aircraft also. So now by superimposing these two curves, we can draw total drag curve. Okay, total drag curve like this. So this is called as total drag. By combining those two, we can get it. So where this point is there, this is the very good point we can say, where we can maintain our steady level flight easily. Okay, so this is about the drag curve. And now we know that our thrust in steady state level flight condition, our thrust whatever is produced is equal to the amount of drag is produced. That means now this drag curve will act as thrust curves. Are you understanding? Now this drag curves will act as thrust curve, because this is applicable for at steady state level flight condition. Okay, that we will see now. So this point is our minimum velocity point or minimum drag point. Drag. So now we'll go back to the thrust curves now. So now, before going to thrust curve, first we will see what is thrust available. And what is thrust required. So basically, thrust available means The whatever thrust is already there, that means your engine is capable of producing that amount of thrust. Okay, so thrust available means what? The available thrust which is given by the engine itself, irrespective of your airspeed, and is already designed for that, for different atmospheric condition, that is designed, which is already available. So that is called as thrust available. And thrust required. Then what is thrust required? So thrust required is, it is a required amount of thrust to maintain steady state level flight. Okay, to maintain steady state level flight. So that is called as thrust required. That means your T must be equals to D. We have to maintain this. Otherwise what will happen? If this is becoming less, your aircraft will not fly further. So in order to maintain this condition, some amount of thrust is required. Okay, because your the airplane is flying in the air, it is also already experiencing certain amount of drag due to airflow. So we have to overcome from that. Okay, that means what? You need certain amount of thrust, right? So that is called as thrust required. To balance the drag, we want certain amount of thrust. So that is called as thrust required to maintain steady state level flight, this condition. And thrust available means which is available by the engine, and that is designed for that condition, and it is already available. So now we have seen a drag curve. So now for this condition already we know that the amount of thrust whatever it is produced is equal to the amount of drag. That means what? The drag curve will now act as thrust curve. Same thing, only we will replace with drag with thrust. So how it looks? Directly we will take the total drag curve in terms of thrust. So this is like this. So thrust required, we'll write, and the curve will be, thrust required curve will be like this, which looks like our total drag curve. And now at this point what we wrote, it was minimum velocity with respect to the lift to drag ratio. Sorry, not minimum, maximum. This is maximum velocity, and this will be your minimum TR, that is thrust required minimum. Thrust required minimum. So this curve is about thrust required. This is nothing but our total drag curve. Okay, but it will be in terms of thrust required. So now thrust available curve. So we have seen the thrust required curve, okay, which is looks like total drag curve. Now we will see how the thrust available curve will be. The thrust available curve will vary from engine to engine. So it is different from different for propeller engine as well as turbojet and turbofan engines. First we will see turbofan engine, sorry, turboprop engine. First we will see the thrust available curve. Okay, thrust available curve for propeller engine. Okay, so thrust available, and this will be your V infinity airspeed. So basically the thrust available will be more, and then it starts reducing. Okay, for propeller engine thrust available will be more, but it starts reducing as airspeed increases. You know why? Because your propeller engine is, most of the thrust is basically it is coming from the rotation of the propeller. That means at the lower speed, it will rotate and it can gain more thrust. But as speed increases, what will happen? Let us say it is about to reach the sonic condition, Mach number 1. It will start experiencing the compressibility effect. That means the stalling starts happening, which in turn reduces the thrust. Instead of giving more thrust, the thrust start reduces. That means the propellers are designed in such a way that for higher airspeed, the thrust available, whatever it is there by the engine, will reduce. Okay, so this is for thrust available curve for propeller engine, and this is happening because of the compressibility effect. Okay, so now for turbofan as well as turbojet engine, thrust available curve will remain almost same. Okay, it will not change, as well as it will remain almost constant. It will not decrease or increase, almost it is constant. It will be like this for turbojet and turbofan. Turbofan is for low bypass air engine, V infinity. So it will be like this curve. Is constant because the engines are designed in such a way that the thrust available curve will remain constant even though you increase the airspeed. Where in case of propeller engine, thrust available curve decreases with increase in the airspeed, because here the compressibility effect will come into picture, where your propeller will experience. So now, after that, what is the maximum velocity? That we will see now. That is different for turbojet and turboprop. Let me see that. So now we will see how the maximum velocity can be taken. Basically, the maximum velocity for turbojet engine is taken based on the thrust available curve as well as thrust required curve. Okay, and we know that this is for turbojet engine. And low bypass turbofan engine. This graph, this is for turbojet engine and low bypass turbofan engine. So now, how our maximum velocity we are going to calculate? Okay, so thrust, and this is V infinity. So TR and TA, both curve we will take. So we know that thrust available will be almost constant for turbojet engine as well as turbofan engine, whereas our curve, thrust required curve will be in this, which we have seen previously, where it was looking like a total drag curve. So this is TR curve, thrust required curve, and this is thrust available curve. So now, imposing both, where these are intersecting at higher airspeed, okay, at higher airspeed, thrust available curve and where your thrust required curve are intersecting at this point is called as maximum velocity point. So we can say that Vmax point. Okay, this is the graphical approach to find out the maximum velocity point using the thrust available and thrust required curves. So now, and one equation is there to find out Vmax. That equation is look like this, which will be in terms of thrust available. Okay, so equation will be so to find out Vmax, we have one equation. So Vmax equals to TA max divided by W by S, wing loading W by S, root of TA max divided by W whole square minus 4 CD naught K whole divided by rho infinity and CD naught. So this is the maximum velocity equation in order to find out the answer for maximum velocity. So TA means thrust available and W means weight, W by S means wing loading, density, coefficient of drag. So this is about Vmax, and here thrust required is equals to the thrust available maximum. That is the condition. Okay, because TR equals to TA. For steady level flight, we are talking about for steady level flight, TR will be equals to TA. So that is the reason TR equals to TA max, we can say. So if we here the Vmax increases when if your TA max and TA max by W increases, your Vmax increases, and then your wing loading W by S increases, your Vmax increases. Okay. When your CD naught and K increases, your Vmax decreases. So these are the conditions. So here we will stop, and in next class afternoon we will see some other topics, maybe power available and power required curves we will see in next class. Thank you. Okay, before going, just I will conclude with the syllabus part. So we have studied about different types of stability conditions and parameters, and then we have seen maneuvers, and we have seen today's class effects of effect of altitude on the engine performance that we have discussed. And here today we have seen many different curves. It may be the drag curve, thrust curve, okay, and all those things for different aircraft we have seen. And next, another two topics are left, that is power available as well as power required curve for your fourth unit. So once it is done, this fourth unit will be over. Next, we will jump into the fifth unit, that is rockets, uh, where in rocket also we have covered the some portion of the rocket in first unit itself, okay, where we were studying the not first unit, it will be that the unit which is having the propulsion related topics, maybe unit number 3. Okay, there we have spoke about different rocket engines, how they will be working, as well as what are the working principle, or which are the working principle of different rocket engines. That also we studied that day. You please go through the notes what you have in your home. Also check it properly, and if any doubts are there, you can always text me or call me, and I will answer those questions. Okay. So now we will continue with the next topic in next class.